is the science of stupid. Warning! You're about to witness multiple acts of extreme stupidity in order to further your knowledge of science. Do not attempt them yourself. Yes! This is the show where we merge intelligence with idiocy in a cornucopia of carnage. As our trusty team of testers explore key scientific principles so you don't have to. Then we explain what went wrong and why. With their assistance, we'll scrutinise the science behind Aeolian regimes, angle of approach, and the perils of reaction force. So don't try any of this at home. Actually, don't try any of it at all. Watch out! It's the science of stupid. In this show, we'll be looking at dynamic friction, the results of the Coriolis force, and lateral forces. But first, this. Did you know we may have flat seas to thank for the invention of skateboarding? Back in the 1950s, Californian surfers, frustrated by the lack of waves, stuck wheels onto boards. 25 years later, skateboarding had taken off properly, and a group of teenagers in the Arizona desert started using water pipes for tricks, and thus the half-pipe was born. Things have really taken off since then. The half-pipe has evolved into a sport in its own right. It's no longer the sole realm of the skateboarder. Anyone with a set of wheels and nerves of steel can get in on the action. But it's harder than it looks. Scientifically speaking, a half-pipe is a pair of brachistochrone curves, a bit like a pipe cut in half longitudinally, sometimes with an added elongated flat central section. There aren't many skaters who could tell you that, but there's a lot fewer scientists who can land a McTwist. Descending the ramp, his gravitational potential energy is converted into kinetic energy and he speeds up. His momentum keeps him going long enough to ascend the opposite ramp and repeat the process. If he can build enough speed, adding energy by pumping with his legs, then the steeply angled ramp will launch him into a vertical trajectory to help him catch some air. Aided by the steepening inclined planes of the half-pipe, riders can achieve speeds that can launch them over 2 meters above the top of the ramp. This allows for some spectacular aerial acrobatics, which sounds fun. Old school. Looks like he's gone back to the grassroots of the half-pipe. And now he's back to the roots of that grass. The shallow angle of the ramp results in a shallow launch trajectory. And with insufficient velocity, he tries to bail out, proving old school isn't always cool. At last, a use for the micro-scooter that doesn't involve annoying pedestrians. This guy launches himself into a steep trajectory that allows plenty of airtime for his trick, but catches himself awkwardly and lands on his feet, where friction slows him quicker than the scooter would have, which means it's not really his day today. This guy seems to have remembered his science: gravitational potential energy, kinetic energy, and momentum. If only he'd remembered his helmet. As he shifts his weight forward to prepare for the up-ramp, he twists the board so wheels are no longer aligned with his momentum, and friction decelerates the board, but not him. He'll have to face it, that didn't go well. So that's half-pipes. A lot of fun, unless that happens. You have to be a really serious weather disaster to warrant getting your own name. Hurricanes have this dubious honour, and it's hardly a surprise. A large hurricane can expend the energy of 10,000 atomic bombs. That's because a Category 5 hurricane has to have wind speeds in excess of 157 miles an hour. And unlike tornadoes, they stick around. The longest, Typhoon John, lasted for 31 days and covered over 8,200 miles. I wonder how far this toilet will get. Whether you call them cyclones, typhoons or hurricanes, they are deadly and destructive. Giant, spiralling tropical storms that build power over oceans before unleashing vast quantities of wind and rain as they make landfall. But how do they form? Hurricanes begin in warm oceans where water evaporates. When this water vapour reaches a certain height, it condenses and forms thunderclouds. These clouds are affected by the large-scale circulation of winds around the globe, which, thanks to the Coriolis force, spins them into a spiral shape. As it grows, a tropical disturbance becomes a tropical depression, then a tropical storm, and then a hurricane. When they make landfall, the intense winds and rain can bring about flooding, structural damage, and storm surges. Some hurricanes can release more than 2.4 trillion gallons of rain a day. That's enough for every person on Earth to take about 20 showers each. So, if you hear a hurricane warning, you're best to take cover where you are, because driving home could prove to be a costly mistake. Wind battering the tops of trees applies a turning force, which they may not have the material strength to withstand. This city in Russia is well known for its space industry, so you'd imagine it would be well made. But you'd be wrong. The fence has a large surface area, and so experiences a large drag force from those hurricane-strength winds. Yeah, I think you're gonna have to go the other way. So that's hurricanes and storms for you. Extreme weather that can cause extreme damage. And a lot of mess. Honestly, it's not worth tidying your lawn until the storm's passed. I promise.